workshop number 2. So this is the one that deals with Mount Carbonyl. We talked a little bit about that. We talked about at the top, and we talked about all these different types of C-double bond O's. And we talked about why they're reactive, why some are more reactive than others. But in all of these, we're always looking at the carbon and the carbonyl. We're also looking at how reactive that is. So here I have an aldehyde, a ketone, an ester, and a carboxylic acid. Right. So I got a couple of these here for us to think about. For the aldehydes, right, they're pretty reactive. And the types of reagents I show here are a Grignard, sodium borohydride, and lithium aluminum hydride. Right. So a C- and 2 different H-. The C- are always really reactive. The H- have different reactivity based on the orbital overlap of boron and aluminum, which we talked about before. So sodium borohydride is not that reactive of a nucleophile. So it needs to match up with something that's higher up, right? Because these are higher in energy. It needs to match up with something that's more reactive because it itself is not that reactive. So in aldehydes and ketones, that's reactive enough, right? But notice when you go to esters, all of a sudden there's no reaction for sodium borohydride because look at they're farther down Mount Carbonyl here. And the same with carboxylic acids. There's no reaction. Right? They're not reactive enough. So what I want you to see is, right, compare the 3 new nucleophiles you've learned about, Gringards and the 2 hydrides, with the different types of electrophiles that you might encounter. Right? So the ester and the carboxylic acid aren't as reactive. And again, always remember carboxylic acid, this is a key point, right? They don't react with Gringards or hydrides, like different ways, right? Gringards especially, they deprotonate. Gringards deprotonates against protonate to give a carboxylic acid back. No reaction with sodium borohydride. And then lithium aluminum hydride, you actually keep reacting. That's the second, you actually make a primary alcohol. Other new things, esters, 2 things add, right? Multiple things add because you have a good leaving group. Right, so Grignard will add twice, sodium borohydride won't add at all, and H- will add twice. So notice you get a primary alcohol here, you get a primary alcohol here, you get a tertiary alcohol here. So those kind of ideas, be thinking about those, but thinking about the different electrophiles and then the different nucleophiles, what they're going to react with. That's kind of the take-home message for this. These are also pretty much all addition elimination mechanisms. This is a deprotonation and then protonation mechanism, this one. But everything else is pretty much addition elimination mechanisms or just addition protonation mechanisms.